Imagine a force that you cannot see, smell, or hear. Something that moves through the world, passing through your body without you even realizing it. This invisible power can heal, but it can also destroy. It has changed history, shaped medicine, and even threatened entire civilizations. This force is radioactivity, and its effects on the human body are both fascinating and terrifying. At its core, radioactivity is energy released from unstable atoms. These atoms break down over time, emitting radiation in the form of particles or waves. Some types of radiation, like the kind used in X-rays or cancer treatments, can be controlled and beneficial. But when exposure is uncontrolled or excessive, the consequences can be severe. Radiation can penetrate deep into our bodies, reaching our cells and even our DNA. Depending on the type and intensity of exposure, the damage it causes can range from mild to deadly. One of the most immediate effects of high radiation exposure is acute radiation sickness. When large doses of radiation hit the body all at once, cells begin to die faster than they can be replaced. The first symptoms might seem harmless: nausea, fatigue, and headaches. But within hours or days, more serious signs appear. Skin may burn, hair may fall out, and the immune system can collapse, leaving the body vulnerable to infections. In extreme cases, internal organs begin to fail. This is what happened to the Chernobyl liquidators, the firefighters and workers who rushed to contain the nuclear disaster in 1986. Many of them were exposed to such high doses of radiation that their bodies simply could not survive. Even when radiation exposure is lower and spread over time, it can still have dangerous effects. The most serious long-term impact is the risk of cancer. Radiation can alter DNA, the blueprint of life inside our cells. When DNA is damaged, cells may begin to grow uncontrollably, forming tumors. This is why survivors of nuclear bombings, nuclear plant accidents, and even workers exposed to high radiation levels have an increased risk of developing leukemia, thyroid cancer, and other deadly diseases. But radiation doesn't just affect individuals. It can change entire generations. If radiation damages the DNA in reproductive cells, the effects can be passed down to future children. Studies on the survivors of Hiroshima and Nagasaki have shown an increased risk of genetic mutations and birth defects in later generations. Even today, researchers continue to study the long-term effects of nuclear disasters like Chernobyl and Fukushima, trying to understand just how deep and lasting these changes can be. Despite its dangers, radioactivity is not always harmful. In fact, we rely on controlled radiation for many medical treatments. X-rays help doctors see inside the body, while radiation therapy is used to target and destroy cancer cells. Even in space exploration, scientists study how radiation from the sun and cosmic rays affect astronauts, helping us prepare for missions beyond Earth. Marie Curie, one of the pioneers of radioactivity research, helped develop medical applications for radiation, but tragically, her exposure led to severe illness and, ultimately, her death. In a world where nuclear power, medical technology, and even space travel depend on understanding radiation, one thing is certain: this invisible force will continue to shape human life. Whether as a tool for healing or a source of disaster, radioactivity remains one of the most powerful and mysterious forces in the universe. As we continue to use radiation in medicine, energy, and space travel, are we fully prepared for its risks? Let me know what you think in the comments.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.